All right, folks, it's Back in action here. In this video, we are going to go through writing equations of conics from some particular characteristics. So you can see on this page, I've got 3 different examples, and we're going to work through how we could come up with an equation for that particular conic based on just these few pieces of information. There are certainly a wider variety of ways that the characteristics could be given, but if you can do these 3 and you understand the characteristics, then you can work your way into any other missing pieces of information. All right, the first one we're going to take a look at here is a parabola. So we want to get a parabola in standard form. Remember that standard form is our new standard form. So what I like to tell students to do when they are starting off with the parabola is to go ahead and give yourself, you're going to have a parentheses and we'll have an X here, and then I'm going to say an equals, and then I'm going to have a Y here. And you'll notice that what I'm not doing is I'm not filling in which side is going to be squared and which side would have the coefficient, because I don't know that yet. So I'm going ahead and I'm laying this out with the X on the left and the Y on the right, so that when I find that vertex, I can easily drop those in. Now, when I take a look at the given characteristics, you can see that I actually gave you the vertex on this one. So since we are automatically given the vertex, we can drop that in and make this an X plus 1, because remember it's X minus 1, and then a Y minus 4. I still don't know which side is going to be squared and which side would have the coefficient, so then we're going to go ahead and we're going to make a quick little sketch. Remember, sketches are just that. They are sketches. They do not have to be to scale, but points should be generally in the proper quadrants. So if my vertex is at a negative 1, 4, I'm going to go ahead and put that right there. And I'm going to put a V next to this one to remind myself that that's going to be my vertex. It's sometimes even helpful to go ahead and write in the ordered paired right next to it. Then the next thing that I've given you is the focus at a negative 1, 0. So right here is going to be my focus. I'm going to put an F next to that, and I can label this as negative 1, 0. So now what this tells me is a good idea of what this graph is going to look like. I understand that a focus needs to be inside my parabola, so my parabola has to look something like this. It has to be opening down with that focus on the inside. What this then tells me is that it's the x-axis that needs to be squared, so I can put my exponent right there, and I know that this right here is going to be 4p. I also can tell from the direction of this parabola that that value, that coefficient, is going to need to be negative. So all that's left to figure out is what in fact is the value of p, and the value for p is going to be the distance between these 2 points. And I can see that the distance from 4 to 0 is of course 4. So I could say that my p is 4, but I'm even going to go ahead and label it as a negative 4 to remind myself that it is supposed to be going down. So then over here, I can fill in that as a negative 16. And that would be the equation for your parabola. All right, let's take a look at an ellipse. The ellipse is going to take a little bit more work. Couple things that I want to point out here is, first of all, it's giving us the foci, and what I want you to notice on these foci is that the x coordinates on each of these are the same. So the only thing that I'm really concerned about when I create my sketch is how the y values are going to be moving. So what I'm going to do is I'm going to draw in just the vertical axis so that I can label in. And sometimes students even like to go ahead and put a 2 on that, representing it as an x value of 2. Then I'm going to have one foci at 2, 5. And again, I'm going to put a little F next to that. And the other one is at 2, 1. I'm going to put an F next to that one. So that's going to help me figure out where my center is. Also, it's going to tell us that my major axis is a length of 20. So what that means is that from our center, we're ultimately going to go 10 in each direction. Now remember, since this was the major axis, then that means that from wherever my center turns out to be, I'm going to go 10 up and I'm going to go 10 down. Now, my center has to be halfway between these 2 values. Now you can probably do it mentally, but just as a reminder, mathematically what we're doing is we're finding the average of that 5 and the 1. So we're going to have a 6 over 2, and that's going to give us a nice 3. So now I know that the center of my ellipse, I'm going to put a little C here, my center of my ellipse is at 2. That's that same 2, because all these have to be oriented the same, and is going to be up 3. So now I've got my center. Oh, I meant that to be a 3. There we go. All right, so now I've got my center. So what I can do over here is I can actually start creating this equation. I know that all my ellipses are going to be a fraction plus a fraction, and it has to equal 1. I'm going to tell you right off the bat, this equals 1 is a thing that students forget a lot, so I would strongly encourage you to write that immediately. So let's take a look at things that we can fill in. We can certainly fill in our center. We know that on an ellipse, the x is always first. So I can say x minus 2, quantity squared, y minus 3, quantity squared. We said that we were going to go 10 in each direction. So from my center, I know I need to go up 10 and down 10. That means that my vertical distance, in this case, we now can see it's going to be vertical. The vertical distance is 10, which makes the denominator under the y a 10 squared, or a 100. So what we're missing here is this value here that's under the x. And what we're going to do is we're going to combine the 10 that we have for our vertical distance with the distance from the center to the foci, and we can see that that distance is 2. So that means that our c value is 2. So using the c value of 2 and this value of 10, we can work with our c squared, and it's an a squared, and remember, it's minus b squared. So c is 2, so I'm going to drop in a 4. This value has to be the bigger. It's always going to be that major distance. So if you want to write that reminder, you can. This is the major distance. And then we're going to square that. So that's going to give us 100 right here, minus a b squared. And now we can see that our b squared value is going to be 96. And that value is the value that is going to go underneath the x. So this will be then a 96. Okay. The last one we're going to do is going to be our hyperbola, and I like to do the same idea that I did on the other one, is I like to take a look at what part's going to stay the same, and this time I can see that all of the y values are staying the same. So when I start plotting my points and creating my sketch, I'm actually only concerned about how the x's are changing. So I'm just going to draw this nice horizontal here. I'm going to give myself a reminder that this is at a y value of a negative 2. So that means that when I'm thinking about my center, that the y value has to be a negative 2 there. We need to figure out what that x value is. So we can start dropping in some of our numbers. The vertices are at a 5 and a 15. So I'm going to have a 5 and I'm going to have a 15. I'm just kind of putting those in order, and we can put V's on those to remind ourselves that the vertices. That does give us enough information to be able to find the x coordinate of the center, because it has to be halfway between those. So if we want to do that right away, you can again either count it, or you can remember that mathematically you're finding an average. Your 5 plus 15 is going to be 20 over 2 is going to give you 10. So that means this is going to be 10. So now if we want to start writing our equation for the hyperbola, we can remember it's going to be a fraction minus a fraction equals a 1. Then we need to think, what direction is this going to open? That's going to tell us whether it's the x first or the y first. So which variable should go here? Well, if my values are oriented horizontally, this means that this has to be a horizontal hyperbola. If these had been oriented like our last example where the values were oriented up and down, then what we would do is we would put the y value first. But this one is horizontal, so we can just drop these in like normal. So x minus 10 squared, y plus 2 squared. So we've got that first amount. So I'm going to fill in my center here. We've already figured out that this is going to be at 10, and I'm going to put a C there for center. Then what I'm going to do is I'm going to grab these foci. The foci are at a 3 and 17. So I'm going to have a foci here at 3, and I'm going to have one out here at 17. What this is going to do is this is going to give us the distance from the center to the foci, and I can see that that distance is 7. Again, we could have gone in this direction as well. So now I'm going to use this 7, and I'm going to use the distance from the center to the vertices of 5. I'm going to use those values in my equation of c squared equals a squared plus b squared. The distance to the foci is c, so I'm going to fill in a 49. The distance to the vertices is 5, so I'm going to fill in a 25. And there's my b squared. So now I can actually calculate that that b squared is 24. That's going to go, oops, I didn't mean that to go under the x there. That's not going to go under the x. It's going to go under the y, because our distance from the center to the vertices of 5, that one's 25. That's going to go here. Ignore that piece. And the 24 is that vertical distance we just calculated of 24. So we've got our 25 here, center to the vertices squared. Under the y is going to be the b value from this little equation. So there we go. That's going to be our equations from our characteristics. And again, if you really just focus on always finding these little pieces, you should have enough to only have one missing variable each time.